चलो कल क्या किया था अभी tomorrow we so we did this part okay. I told you that if we talked about electronegativity, which is that it increases to the right. ठीक है ये corner जो है that's remember fluorine is one of the most electronegative elements ठीक है. I mean it really likes to gain electrons. और वो जो दूसरा corner है that's the least electronegative. They don't like to gain electrons. Francium is like francium एक तो दुनिया में exist नहीं करता. Francium is the most rare element, but it's got a very low electronegativity as well. अच्छा, but anyways, and I told you that based on that you'll have a spectrum of different compounds. ये मैंने कहा था कि you get ionic compounds if there's a very large difference in electronegativity, which means when you have a large difference कि एक atom इधर है और एक atom दूसरी side पे, you've got a large difference. One is on the right side, one is on the left side, but it has to be greater than 1.7. It has to be only then will it have more ionic properties. And we'll discuss what ionic properties are. इसके अंदर होगा कि if you've got a very large difference in electronegativity, then one of the atoms will gain electrons, and the other one would end up losing electrons. The one that is not electronegative. और covalent का मैंने discuss किया था कि covalent is when you have a very small difference in electronegativity, which is less than 1.7. In that case, what happens is no one ends up gaining or losing electrons. Both of them have an equal tendency to actually gain electrons. So they both try to gain electrons. It's like a tug of war that's happening between them, and when electrons are stuck in the middle, the electrons can't go to the right or they can't go to the left. They're exactly stuck in the middle. That's sharing of electrons. So इसको बस पहले quickly discuss कर लेते हैं कि we have ionic compounds, and I'm going to do the properties of ionic compounds. And remember, it's going to be a spectrum, ठीक है? So each में ना you'll also have within this spectrum you will also have lots of polar covalent compounds. Covalent molecules or compounds, and I'll explain what that is. Okay, I remember it's a spectrum. So what that is, okay, you might have a molecule where, for example, I've got HCl. Okay, so I've got Cl. इसको जरा side पे कर लेता हूँ. So in this case, these were perfectly covalent molecules because they absolutely had no difference in electronegativity. Difference to the less than 1.7. Actually, there was no difference. But then you'll have molecules which will have some difference, but that difference is not large enough. Okay, so you've got Cl. The Cl ke paas hai, it's got 7 electrons in its outer shell, and you've got hydrogen, which is it's got 1 electron. Okay, so hydrogen over here has just 1 electron. Now, what will happen in HCl is that there is a difference in electronegativity. It's less than 1.7. Cl जो है ना, that's 3, or hydrogen जो है ना वो it's 2.1. So one of them is 2.1, the other one is 3. So difference obviously less than it's less than 1.7, right? So they're going to try and pull each other's electrons, but no one has enough strength to pull those electrons. What will eventually happen is that the electrons will be stuck in the middle, and they will end up forming a covalent molecule. So the 2 electrons will be stuck exactly in the middle. Okay, so your 2.1 and that's none of them are strong enough to actually pull the electrons towards themselves. So the electrons are stuck in the middle. अच्छा, लेकिन यहाँ पे अगर देखोगे ना, one of them is slightly more electronegative. ठीक है, although the difference is not huge, but one of them is very slightly more electronegative. ठीक है, तो यानी ये वाला केस था, this was a perfectly covalent molecule because both atoms had an equal electronegativity, which means that they pulled the electrons with equal force. Okay, this was 2.1, this was also 2.1. So the electrons were now either ja rahe, now udhar ja rahe. They're being pulled with equal force, right? So the electrons were exactly in the middle. But in this case, the electronegativity difference is still less. So it is a covalent molecule, but one of them is slightly more electronegative. Okay? So what happens is the electrons are not exactly in the middle. In this case, what happens is the electrons will be very slightly, not like an ionic compound. Ionic compound with electron CL gain kar jata na. In this case, the electrons are just very slightly closer to one of the, they're closer to one of the atoms, which is in this case would be Cl. Each two electrons, they'll be closer to Cl compared to hydrogen. So this side will become slight negative, and this side will become slightly positive. Because electron distribution, that is slightly more towards Cl because it's slightly more electronegative. So that's a polar compound. Like it's got slight charges, just very slight charges, but not like an ionic compound. Ionic compound में तो वो electron खींच के एक ही atom ले जाता है ना, because you've got a huge difference in electronegativity. But in polar covalent molecules, they have just very slight difference in electronegativity. ये बात clear है?
Yep.
अच्छा, so our property. So remember, you've got a spectrum. Large difference, ionic. No difference, perfectly covalent. Okay, electrons right in the middle. Some slight difference, then it's still covalent, but it's slightly polar as well. That means slight charges on either ends. Electrons would be closer to one of the atoms compared to the other one. तो अब ये कि बाकी वो clear है, Zaviba, is this clear? Salar clear है? अच्छा, ये कर लेते हैं कि अच्छा we quickly properties of ionic compounds. अच्छा, properties of ionic compounds. First thing, ionic compounds are they've got ions and they form a giant ionic lattice. तो ये साल जल्दी से कर लेते हैं. It's all O levels. They've got giant ionic lattice. That's their structure. Okay, what is a giant ionic lattice? It's a lattice of it's a regular arrangement of positive and negative ions. So it's a regular arrangement of positive ions attracting, of positive and negative ions, and they're held together by strong attractive forces, which are ionic bonds. So held together by strong electrostatic forces known as ionic bond. Known as ionic bonds. So you've got lots of positive ions. It's going to be a giant lattice. You'll have one positive ion. So you'll have one positive ion that's going to be attracted to a negative ion that's going to be attracted to a positive ion, which will further be attracted to positive and negative ions will be attracted to each other. Positive, negative, positive, alternating hoga. You can't have two negative ions together in the lattice. So there's going to be another layer. So there's going to be, they'll all be stacked on top of one another. Okay, so so it's going to be a three-dimensional arrangement, and every one of them will be stacked on top of one another and alternatingly attracted. The or कोई large gaps, they'll be very strongly attracted to each other. So that's your ionic lattice. It's a giant structure. As its properties, number one, they've got high melting and boiling points, and the high melting and boiling points, it depends on one thing, which is known as charge density. The greater the charge density, the stronger is the attraction between the ions in the lattice. So greater charge density, and that would basically correspond to stronger ionic bonds. And that would mean it's going to correspond to stronger ionic bonds. So it's a strong structure. Marble, etc. These are all ionic compounds. Cement, concrete, that's all ionic compounds. So that will correspond to strong ionic bonds and ionic lattice. The crystal is going to be very strong. So the question is, what is charge density? Charge density is when will the lattice be strong? When the first one, the charge on the ion is larger. अगर ये +2 होता है and that is -2, then the lattice would be stronger. So instead of +1 and -1 attracting each other, +2 and -2 will attract each other with a lot more strength. Those are the force of attraction. So charge density is that it's proportional to the charge. Like the greater the charge on the ion, stronger would be the lattice, and it's inversely proportional to the size of the ion or the ionic radius. So it's inversely proportional to that. What that basically means is that छोटा ion होगा ना, तो they'll be closer together. Like if this negative ion was smaller in size, right? If it's smaller in size, they'll be more tightly packed together. They'll be closer to each other, and the force of attraction is going to be stronger. Positive or negative will be closer to each other. The bigger the ion, the further it is from all the rest of the ions. So छोटे ions जो होते हैं, they can be more tightly packed together. They'll be closer to each other, and that will generate more force. So you got two factors. One is so charge density is how dense is the charge on the ion. यानी अगर मैं कहूँ ना कि I've got an ion, a really small ion, and it's got a +3 charge. Let's say that's aluminium ions. It's a small ion. It's just got two shells, and simultaneously I've got a very big ion. Let's say the potassium ion, and it's just got a +1 charge. ये मुझे तो कि इनमें से किसकी charge density ज़्यादा है? Like
Al+3.
Al+3. That's got a higher charge density. Okay. Al+3 is going to generate more attraction. Al+3 will be smaller, so it will be more tightly packed. They'll be closer to each other, and ऊपर से charge भी ज़्यादा, so that would lead to more attraction. So ये वाला जो है, that's got as this one over here has got a higher, as it's got a higher charge density. Remember this fact when it comes to ions. The ions that are smaller in size and that have greater charge, they're the ones that generate more attraction. I'd say the number one हो गया. They've got a strong structure. Structure के ऊपर भी आ जाते हैं. Ionic compounds can have really strong structures. So strength of ionic compounds. Some ionic compounds, because of their strong structure, known as ceramics. ठीक है, ceramics. So ceramics are ये आपकी sinks वगैरह बने होते हैं ceramics से. So ceramics are ionic compounds, like really strong ionic compounds. ठीक है. So really strong. Really strong ionic compounds. Two of them are really strong. Like you've got magnesium oxide, that's a ceramic material that's used in refractory lining, furnace lining. Or Al2O3, that's also a ceramic material that's used in electrical appliances or electrical applications. So आपका जो switch board होता है ना, that's made out of Al2O3. ठीक है, it's a ceramic. It's घरों के बाहर लगा होता है, ठीक है. So I mean, I'll just show you because it's not going to melt. It's a very tough thing. So ये सारे भी ceramics हैं, ठीक है. Your switches even a lot of times are made of ये खास तौर पे ना. I mean, all these things ये तो clear नहीं है, ठीक है. ये जो the material that's used for making this, that's ceramic, so that no one gets electrocuted. It doesn't really melt. Even if it catches fire, nothing happens to it. Okay, so they're really strong ionic compounds. Charges भी ज़्यादा, it's +3 and -2, so there's more attraction. NaCl will not help because NaCl is a weak lattice. Okay. अच्छा, फिर simultaneously you've got और क्या properties होती हैं? They conduct electricity when they're molten. ठीक है, so that's another one. So conduct electricity only when they're molten. So ceramic materials ko na, you can't even melt them. They've got very high. Magnesium oxide has a melting point that's very close to diamond. So उससे जब melt ही नहीं होना, तो it's never going to conduct electricity. So they conduct electricity when they're molten. I mean, you can melt NaCl, but even NaCl has a very high melting point. That's 800 degrees centigrade. और दूसरा है कि when either it's molten or aqueous. Why? Because in that
where we can obtain the MgO in molten form, right?
ये melt कर सकता है, लेकिन it's got a very high melting point ना.
सर और ये aqueous हो सकता है, यानी ethanol में भी
dissolve भी नहीं होता ना, मतलब एक तो melting point
सर ethanol में भी.
ethanol में
जी सर
नहीं, melting का मैं explain करता हूँ कि एक तो उसका melting point 2852 है, ठीक है, that's very high. तो sodium charges कम होंगे ना, Na+1, तो melting point is pretty low, right? Like all of a sudden when the charges are high, +2 -2, the melting points are. मैं देख लेता हूँ magnesium oxide in ethanol. I don't think it dissolves. Ethanol क्यों कह रहे हो?
तो ऐसे वो solvent है जिसमें काफी चीजें dissolve होती है जो water में नहीं होता.
ये organic non-polar चीजें dissolve होती हैं, वो मैं explain करता हूँ. It's not. इसका मैं solubility का एक rule भी बताता हूँ ionic compounds का, ठीक है? So you'll understand. अच्छा, so they conduct electricity with molten or aqueous, ठीक है? But MgO will probably not conduct because it's going to be pretty hard to actually dissolve it, ठीक है? ये clear है?
जी सर.
और NaCl को भी मेल्ट करना मुश्किल काम है. मतलब NaCl को भी नमक को चूल्हे के ऊपर लेके जाओ ना, नहीं होगा मेल्ट, ठीक है? Even NaCl is sodium oxide 1100 degrees centigrade. तो I don't think your flame, वो जो आपका burner होता है ना stove का, that doesn't really have 1100 degrees centigrade. So it's pretty hard to actually melt them in the first place. But they do conduct electricity when they're molten or aqueous. Why? Because they've got free moving ions. So the ions will start moving around. अच्छा, solubility का क्या है? Solubility varies. quite an extent. But most ionic compounds, they do dissolve to a very varying degree. अच्छा, dissolve करने के लिए पहला काम क्या करना होता है? Like if I've got an ionic compound, right? अच्छा, remember ionic compound का dissolve करने का rule जो है ना, that's this. Let's say you've got 4 ions. You've got a crystal and it's got 4 ions. What will happen is they're all attracting each other very strongly, right? NaCl कर लेते हैं. This is NaCl, +1 and -1. +1 ion, -1 ion. ठीक है, so they're all attracted to each other. जब आप इसको mix करते हो ना, the first thing that you do is you stir it in water, and when you do that, the ions they get scattered. ठीक है, so the ions, all of them will scatter, or they will dissociate. ठीक है, which is that they will separate from each other and they will be swimming around separately. ठीक है, positive ion, negative ion, positive ion, and they're all surrounded by small tiny water molecules. ठीक है, so you've got billions of these water molecules. Billions तो नहीं होंगे, you'll be counting them in moles. Moles is a much bigger number than a billion. अच्छा, but you've got thousands and billions of small water molecules that are in the way. So that's what solubility is, right? ये clear है? Ionic compounds, they dissociate in water.
Yes, sir.
But only dissociate if they dissolve. To dissociate when they're aqueous. तो मुझे इसको देख के बताओ कि why do some ionic compounds dissolve and why do others don't dissolve? NaCl तो dissolve हो जाता है. It turns into Na+1. But the ions they separate, right? What if the lattice is very
Well,
strong? अगर crystal बहुत ही strong है, जैसा marble नहीं है जो marble tiles होती हैं. Calcium carbonate होता है ना, one of them is +2, the other one is -2, the one of them is +2, the other one is -2. So calcium carbonate, let's say limestone. So high forces, the Weber is high force of attraction. So you've got a very high force of attraction. Marble could, you put a marble in water and you keep stirring it, you keep shaking it. The attraction is so strong that the lattice does not break. It does not dissociate in water, right? The ions just keep on sticking with each other. So it never mixes in water. Is that clear? Okay. Clear?
yes, sir.
Plus, I mean, your concrete, cement, etc. That's also ionic, right? That's also a form of limestone. So that's also ionic. So that will not dissolve as well, no matter what you do. Isliye wo strength bhi itni zyada hai, they're all, the ions are sticking to each other. So NaCl was very weak. चम्मच हिलाने से भी ना वो dissociate कर जाता है, right? NaCl को तो हल्का सा stir करो, I mean the ions just break away, right? So that's a rule. I mean, so you can come up with a rule which is, if the ions have low charge density, then it's most likely soluble. Group 1 की चीजें क्यों soluble होती है? Because group 1 ions, they don't attract the other negative ion that strongly. So which is why group 1 compounds are usually soluble. एक तो ये कि low charge density, then it's probably soluble. And vice versa, if it's got a very high, if it's got a very high charge density, or even ions की बात कर रहा हूं, if they've got very high charge density, then probably not soluble. ठीक है, वो कहा कि aluminium oxide not going to dissolve. एक वो केस भी होगा, केस भी पढ़ा है, नहीं पढ़ा? वैसे ही तो आप लोगों ने पढ़ा ही नहीं है, ठीक है, वो A2 में होगा. I mean KSP values, value of Al2O3. As a KSP is something, it's a solubility product. It just gives you an idea of of how soluble is something. तो असली यहाँ पे दिया हुआ शायद like this. Yep, I've got different KSP values. अच्छा, okay, you'll study this in A2. Sorry. KSP values. Okay, anyways, you'll notice a trend. So you'll notice a trend. The smaller the value, the less soluble it is, right? So you've got these are your KSP values, right? Just remember the idea that smaller the value, less soluble. So ALPO4, therefore, that's minus 21. That means it doesn't really dissolve. It doesn't. Minus 21 is such a small value; it doesn't dissolve. Plus 3, PO4 minus 3, so there's a strong attraction. Plus 3 is, so that's big value, right? So things, when do things become more soluble? Group 1 ka kidhar hai? Just once again, sodium. Do we have sodium? NaLMN. Achha, Na hai. Achha, K. What K? K ka dekho, K plus 1. So that's more soluble. Minus 2, minus 4. That's relatively more soluble. So smaller the charge, more soluble it is. Okay, idea clear? Is this clear? तो आगे ये कि बस और तो कोई प्रॉपर्टी नहीं है, that's it. ठीक है, that's ionic compounds. Well, there's one more property which is that they're brittle. ठीक है. So so there's one property, and that is ionic compounds happen to be brittle. So they can be very strong, but when it comes to breaking them, the whole thing shatters. Okay? If you have a marble tile can last years. Okay? But गलत तरीके से hammer उस पर लग जाए, anything falls, it breaks and shatters into pieces, right? So why do they lose their strength all of a sudden? तो वो भी उसके lattice से उसका ताल्लुक है कि if you've got an ionic lattice, right, like this one, so the lattice can be really strong. I mean, this lattice can be extremely strong. Like you want to move this, I say positive, it should not be positive. And voila. You can't have, so I've rubbed it off. Okay. Negative point out there. So it's so strong that I can't remove this negative ion from its position because the positive ions over here, they're attracting it. Okay, so it's pretty strong. I can't move any one of them. In beach, if I want to remove the positive ion, I can't do that because it's attracted to negative ions from all sides. So I can't really move it. Okay? But if I were able to sort of apply a strength in a way, say beyond a certain limit, if I apply enough force and I'm able to move one of the layers, तो फिर क्या होता है कि you got two positive ions together, you got two negative ions together. So all of a sudden, instead of having a force of attraction, you instead get a force of repulsion, and that's where the cracks develop. यानी अगर एक टाइल को एक एंड से हैमर करोगे ना, it's going to crack all the way to the other side. ठीक है, so is this clear that why they're brittle? Clear?
जी sir.
So let's move to covalent compounds now. So you've got covalent compounds, and you've got covalent, and you've got polar covalent compounds. इनकी ionic compounds की the properties relatively simple है, mostly O levels, but covalent molecules, we're going to take a much deeper dive in that. Okay. So covalent molecules. Now what happens is you've got different types of covalent molecules. The basic structure is for a covalent molecule is it's a simple, better with general properties. It's a simple molecular. It's a simple molecular lattice. What that means is that you've got a bunch of molecules with weak intermolecular, with weak intermolecular forces. With with weak intermolecular forces. With weak intermolecular forces, and a simple molecular lattice with weak intermolecular forces. Now the thing is कि अच्छा एक सेकंड मेरा with weak intermolecular forces, ठीक है. So simple molecular lattice with weak intermolecular forces. और क्या होता है इसमें? Plus you've got okay, it's अच्छा ये होता है इसका सिस्टम. एक सेकंड, सॉरी डिस्टर्ब हो गया था. अच्छा, if I've got a hydrogen molecule and I've got another hydrogen molecule, most of these molecules are kind of interdependent, and the molecules will be they will be flying around and they will not be attracted to each other because they don't have a charge. Okay, so there's going to be all these there are going to be all these weak intermolecular forces and they'll just be flying around. Okay, so that is what the structure of a covalent molecule usually looks like, and which is why they'll have low melting and boiling points. So which is why you've got low melting and boiling points, and because they're all just flying around, okay? And there will be no electric conduction. And I'll have because they don't have any charge. Okay? There's no charge, there's no free moving electrons or anything. Plus the last thing is the very last thing is और क्या property होती है? That's low melting and boiling point. That's pretty much it. So they're mostly low boiling point liquids and gases. ये सारा clear है? Clear covalent molecules, right?
जी sir.
As the only thing I'll do now is we're not going to discuss ionic compounds that much, TK, in AS, sorry, A2 बार कह रहा हूँ, because that's pretty much it. Ionic compounds are kind of simple. The covalent, that's got a lot of things going on. Like this is the picture of a covalent molecule. You got two hydrogen atoms joined together, and the two hydrogen atoms joined together, right? Two hydrogen atoms joined together, and the molecules are flying around. Okay, so we need to discuss it in a lot of detail. What type of intermolecular forces exist between them? Like, are they strong or are they weak? Mostly they're weak. I mean, they're obviously weak. But relatively speaking, some of the times it's going to be strong. Like water molecules, they're in liquid state, so that means the intermolecular forces are strong. Carbon dioxide is a gas. Hydrogen is a gas, so the intermolecular forces are extremely weak. Sometimes they can be solids as well. This iodine, it's a solid, so in that case, the intermolecular forces are strong as well. So ये सारी चीजें तो ये फिर हम डिस्कस करते हैं नेक्स्ट क्लास में, ठीक है? बट we'll take a very it's going to be पहले तो shapes पढ़ेंगे. We'll study you've got covalent molecules. We'll learn how to draw the structures of covalent molecules, and then we'll learn about the shapes of these covalent molecules, the electronegativity differences, polarity वगैरह के बारे में पढ़ेंगे. We'll talk about the different types of intermolecular forces that exist between them. So this is something that we'll cover in a lot more detail. Ionic compounds, that's it. That's pretty much it. ठीक है? तो फिर next class में ना फिर इसी को फिर further expand करेंगे, ठीक है? Is that clear?
जी sir.
तो चलो ठीक है, ये फिर कल अगली क्लास में करते हैं, ठीक है?
Okay. Allah Hafiz.